Okay, let me explain why I was researching that. Um, so basically, in this video, bench tip number 7, PCB etching household chemicals, this guy uses equal parts white vinegar and hydrogen peroxide mixed with a couple, I don't know, like a teaspoon of salt to create his own copper etching solution. Normally they use ferric chloride, but that's expensive, and it's not using household stuff that everyone would have. Um, Now this creates cupric chloride, which is harmful in that it gives off chlorine gas. But a lot of this stuff's harmful. You need a well-ventilated area. That's a no-brainer. Now, this is a very powerful etchant, meaning it consumes copper. Now the reason I'm interested in it, besides obviously using it for copper etching PCBs, if I ever decide to go that route in making PCBs, which at this time I'm not intending to really. Instead, I'm planning to make PCBs using silver glue, conductive silver. But that's another video. What we're trying to discuss right here is that white vinegar and hydrogen peroxide and salt, equal parts white vinegar and hydrogen peroxide. This guy uses 250 milliliters of each in a measuring cup. There's a milliliter measurement as the right side of these lines. These are cups, these are milliliters. He uses milliliters. Equal parts, and then about a teaspoon of salt, and that creates his etchant. Now an etchant consumes all the exposed copper on the board. My idea is to put copper wire of any given gauge into a bowl of etchant, and then agitating that or just letting it sit for a long time, however long it takes, until all that remains is just the insulation. The copper was eaten out completely, leaving just the insulative tubing. And we can get this insulation then in any diameter by dissolving out the copper inside the insulation. Now, why am I interested in getting hollowed out insulation tubing? Well, you can buy vinyl tubing from the hardware store, but you can only buy it in, pretty large sizes used for plumbing. You can't buy vinyl tubing in 24 gauge or 28 gauge or 30 gauge, tiny stuff. Why would I want that? I'll tell you why I'd want that. Multiple reasons, actually. For small vessel channels to send water or air to key areas of the robot, for humanoid robots or any type of robots, for the air cooling. I can send air through artificial lungs through tiny lines, just like the arteries and veins of the body sends blood. I can send my air through, or I can send different types of oil through that are non-damaging to electronics. Such as, I believe, vegetable oil. I can send that through as a coolant and send that into maybe some copper piping that's been smashed flat and pressed against a motor, and then have it return back in a loop. But I can create my own lines for sending of fluids. Very fine lines for very small scale stuff. We're talking about flexible, small scale piping here. Of fluids for liquid cooling systems, as well as air for air cooling. So you could have these little tubes just end in a hole and have the air blow out, and it'd be forced air through artificial lung system. Or it could be compressed air using a small compressor I could design, but I think of artificial lungs as being a type of compressor, and I like that design. I think it's really neat. So I'm planning to have artificial lungs in my robot that will squeeze the air through these little tubes, blowing the air directly onto various parts, which will cool those parts. And then I'm going to have additional air tubing to vent it out. So the hot air will go through hot air exhaust tubing. Now I need to make small tubing for all of this to work. In addition to very small tubing, inexpensive because I'm just using, scrap electrical wire, which I can find in dumpsters, and just strip out all the copper using this etchant, just leaving the tubing. In addition to tubing for air and liquid cooling systems, I need tubing for the muscle actuation system. So I'm going to have little motors that turn and act as pulleys, winding up, kind of like a fishing reel, winding up line. And that will be connected to various joints the same way muscles are connected to bones. The various joints will be made of artificial bone, made of composite materials, wrapped in what's it called? Adhesive transfer tape, double-sided tape, and then wrapped in spandex cloth, or wrapped in nylon 1000 denier or 500 denier cloth. And so that way the bones all contain a cloth outer layer that's tightly connected to it, and then you can sew on the ends of the muscles into the bone wherever the attachment points are going to be, just like the muscles of our body are connected to tendons, which connect to our bones through connective tissues, and that way our muscles can bend our bones, can bend our joints. So that's how my motors are going to tie into my bones for various robotics applications. And in order to send that string to the different muscle tie-in points, sometimes that string needs to make a turn. And in order to make a turn, a string, let's say the string were running along the back of my arm, and it were going to a motor here, and then that was going to go to a motor in the finger, or actuate a finger, but the motor's placed here for this finger. Well, whenever I bend my arm, the finger would bend then, because the string would be made longer when the arm bends. So how do we make it independent of that? You got to add some slack to it and put it through a hollow hose. The same principle applies with the brakes on a bike. If you ever wondered why the bike brakes, the little handle brakes, have a wire coming out, it's steel braided wire that goes through a rubber tubing, and that rubber tubing has a lot of slack. It's so that when you turn your bike, it won't cause the brakes to pull. I try to connect the brake handles from there to the brakes without rubber tubing, and when I turn the handle, the brakes deployed. And I was confused, like, why is that? It's because the tubing makes the string artificially longer, because the string has to fit the length of the tubing. So you can make the tubing plenty long with lots of slack, so that whenever turns happen in the machine, the length of the string is not affected, because the string is artificially made longer by the tubing that contains the string. So that's why you need hollow tubing to make any turns in machinery, so that the string that actuates the actuator is made artificially longer or given slack, and that way any turns made or any moving parts do not affect that string, do not cause it to deploy. So that's why we need hollow tubing, the same way that bike brakes need hollow tubing that has plenty of slack in it. And I always wondered, how would I be able to get hollow tubing that's so tiny that it's just used for, moving little finger joints that don't need thick wire or thick tubing like a bike brakes would have. And also that can run through a finger without having a big lump of tube showing, because I want the humanoid robot to look human. So all the muscles need to fit within the form factor of a finger. So it has to be tiny stuff. So I can use like 30 gauge, really tiny electrical wiring, melt out all the copper using this etchant, and now I've got the tubing. And now I could run string through that, upholstery thread, or fishing line, and actuate my bones in that way. So that's where I'm going to get my tubing, and that's why I needed to know about this. So I'm going to be taking notes on that here.